Assalamualaikum and hi Dr. Kumal. My name is Farisha Nurjana binti Muhammad and today I'll be presenting the identification and characterization of my unknown compounds in my binary mixture through this experiment. So in this video, I will walk you through the techniques that I use, including IR and NMR spectroscopy, as well as the reasoning behind how I identify both unknown compound structures. So the main objective of this experiment was to identify and characterize two compounds that I isolated from an unknown mixture. The process began with the acid-base extraction, which allowed me to separate the acidic component from the neutral one. And after separation, I used TLC, thin layer chromatography, solubility tests, and also spectroscopy techniques like infrared IR and nuclear magnetic resonance NMR spectroscopy to analyze and identify the structures of the two compounds. Without further ado, let me walk you through the general approach that I took in this experiment. So firstly, I performed thin layer chromatography or TLC to confirm that there were two separate compounds that present in the mixture. Following this, I conducted a liquid-liquid extraction to distinguish between the acidic and neutral components. The compounds were then purified and I tested with the functional group test and solubility test. And after that, I used IR spectroscopy to match the functional group with the result of functional group test that I did manually. And finally, I used H1 NMR and carbon-13 NMR to determine the structure of both compounds. And I will now dive into the specific of each technique and the result that I obtained. So the first one is thin layer chromatography. TLC was the first step that I took to confirm the separation of the two components. I applied the unknown mixture onto the TLC plate, developed it in chamber that have a solvent system and then observe the plate under UV light. As we can see the picture that I attached here, the result showed two distinct spots indicating that the mixture indeed consisted of two separate compounds. So this preliminary observation was crucial as it guided my further separation and identifications. Because after I done with this TLC plate, I observed that my unknown compound consists with acidic and neutral components. And furthermore, TLC essentially confirmed that I was dealing with a mixture of compounds that had distinct polarity. Hence, I can proceed with that specifically identification work for neutral and acidic parts. So next, I move on to solubility test to differentiate between the acidic and neutral components. I begin by dissolving the mixture in water and then I tasted it with both sodium hydroxide and hydrochloric solution. The acidic component was soluble in sodium hydroxide, which suggested it had acidic functional groups, while the neutral component was not soluble in sodium hydroxide at all. This hinted that the neutral compound didn't contain any basic or acidic functional group but likely had a different polarity. Next one, I carried out an acid-base extraction. I added hydrochloric acid to the mixture which helped me to extract the acidic compound as it reacts with the bases to form salts. Then, after that, I extract the neutral compounds with DCM or dichloromethane. So the separation process was straightforward and I ended up with two distinct components that are ready for further analysis. One is acidic and the other one is neutral. Next, after the separating compounds, I first analyzed the acidic components based on the results and physical properties that I observed. So I identified this compound as 4-butyl benzoic acid. It appeared as a yellow solid, which is typical for substitute aromatic carboxylic acids and upon closer inspection, the observed melting point was around 158 to 163 degrees Celsius, which closely matched with the literature value of 165 to 167 degrees Celsius. So this gave me more confidence that the compound was indeed a frothed butyl benzoic acid. However, before I deciding this compound, I have done all the manual functional group tests and solubility tests. After that, I matched my result with the IR and NMR spectrum. So let's go with the test that I did for acidic compounds. The first test that I took is Lausanne test. So this test is to confirm the elemental composition of this compound. I perform Lausanne tests and that are quite helpful in detection of elements like nitrogen, sulfur, and halogens in organic compounds. And for my unknown acidic compound, the test showed no presence of sulfur, nitrogen or halogen, which was consistent with its structure for third butyl benzoic acid. and confirming it was indeed a carboxylic acid with no additional heteroatoms. Next, I continue to use a series of functional group tests to further verify the presence of key functional groups in the unknown of acidic compound. And the reaction with potassium permanganate indicated the presence of the conjugation, and the result is positive, which is typical for aromatic carboxylic acid. I then also carry out Brady tests, resulting in a yellow precipitate confirming the presence of a carbonyl group. Since this is a part of the carboxyl group, it was another strong indicator of the compound's identity. And for the last test, which is Hinsberg test, actually I feel that my unknown of acidic compound have any of amine group or amide group, because I'm suspecting that my list sign test for nitrogen was have any contaminate, so that's why it doesn't turns out to be a Prussian blue. Because I'm a bit worried why does my Lazan test show negative for all results. So I really think that my compound should have at least any one of it, maybe amine or halogen group. And finally, I did a Hizbut test, and turns out the Hizbut test resulting a negative result that really convinced me hard to believe that my compound actually really does not contain any amine or amide functionality or any halogen in it. So we move on to the IR spectrum. The most prominent peak was at 3372.04 cm, which corresponded to the OH stretch of the hydroxyl group, and this broad peak is characteristic of a carboxylic acid and show the compound is indeed an acidic substance. And another key peak that I observed was at 1691.52 centimeter, which corresponded to C-double-bond-O stretch of the carboxyl group. And this is a very characteristic feature of the carboxylic acid itself. And the rest of the spectrum also show typical aromatic stretching vibrations around 1600 centimeter, which confirm the presence of the benzene ring, and this combined result from the IR spectrum give me a strong indication that the compound was a 4-tetrabutyl benzoic acid. And next one, I examine the H1 NMR spectrum of the compound. And the peak that I saw at around 7.4 to 7.9 ppm were due to the aromatic protons on the benzene ring. And these protons appear as a multiplet, which is typical for aromatic system. And the singular at 1.1 to 1.3 ppm corresponded to the third butyl group, which was attached to the aromatic ring. In the carbon-13 NMR spectrum, the carbonyl carbon of the carboxyl group appear at 170 ppm, a clear indicator of its presence, and the aromatic carbons were found at 120 to 140 ppm, and carbon atoms of the type butyl group appear at 30 to 35 ppm. And all of these data actually confirm that the structure of my unknown acid is 4-tetrabutyl benzoic acid. And actually, I really enjoy analyzing the spectrum results to identify my unknown, because somehow it made me feel some adrenaline rush to solve it. Like, I want to solve it faster, I want to get my actual compound, and I'm have a bit of curiosity to know what exactly my compound have and doesn't have, and I just love the way that it's structured for me to try, analyze, and solve it to get the right one. And of course, with the help of doctor, I can get my unknown acid structure, and doctor really helps me a lot to connect the dots within my result until I got the actual one. So that one is for my acidic part, and let's continue to the neutral compounds. The second compound that I isolated was a neutral component, which I identify as a 4-phenyl-3-butane-2-one, a conjugated ketone, and the physical properties of this compound, including its pale yellow solid appearance and sweet odor, suggested a conjugated system, and the melting point that I observed was around 39 to 42 degrees Celsius, which matched the literature review, confirming its identity. And just like the acidic compound, I perform a Lazan test on the neutral compound to check for the presence of heteroatoms like nitrogen, sulfur, or halogens. And same like the acidic, the results were all negative, confirming that the neutral compound did not contain any of these elements. I then proceeded to functional group test. The neutral compound reacted positively with potassium permanganate, a typical test for conjugated system indicating the presence of conjugation between the carbonyl group and the C double bond. Additionally, Brady tests give me a yellow precipitate, confirming the presence of the carbonyl group. And I add on some extra tests, which is shift and tolerant test, that resulting both negative, which rule out the possibility of an aldehyde functional group, but confirming me to have a ketone functionality. So next, I move on with the IR spectrum. Okay, so the IR spectrum for neutral components show a strong peak at 1679 centimeter, which corresponded to the C double bond O stretch of the ketone group, and the aromatic CH strength appear at 3063 centimeter, while the conjugated C double bond stretching appear at 1595 centimeter, confirming the conjugated system. So this IR result match with the expected functional group for a conjugated ketone. And moving on with the H1 NMR spectrum of the neutral compound, we can see a meta group at 2.391 ppm indicating the ketone attached to the alkene. The protons of the conjugated alkene appear at 6.703 to 6745 ppm, and the aromatic protons appear as a multiplet between 7.403 to 7.552 ppm. And next one is for the carbon-13 nanometer spectrum. The carbonate group show up at 198.59 ppm, indicating the presence of a ketone, and the rest of it were consistent with aromatic carbons and the conjugated alkene, which confirming me the structure of my neutral compound is 4-phenyl-3-butene-2-one. So, in conclusion, the unknown mixture consists of 4-tert-butyl benzoic acid for acidic part and 4-phenyl-3-butene-2-one for neutral part, both of which were successfully separated and characterized using TLC, acid-base extraction, and spectroscopic technique such as IR and NMR. The combination of these techniques provide a comprehensive analysis and allow me to have a clear identification of both compounds. And last but not least, I really enjoy myself to elucidate my unknown compound, especially to assign the proton and carbon using the spectrum results. For me, it really interesting and require high attention and of course a strong background for spectroscopic analysis. Not only we are focusing at one peak, but also I really need to go through of each other peak to isolate either the proton have any of electron withdrawing group EWG or EDG donating group that can influence the ppm of the other peak. And also I need to take care of the intensity of the peak that provide a crucial observation for me to take note during the identifications. So I think that's all from me for this course, practical of organic tree and experimental to elucidate my unknown compound. That's all from me. Thank you, doctor.